x cubed minus 1, and we need to show that the roots of this cubic equation are such that 1 plus omega squared equals 0, or we could say w, could we? 1 plus w squared equals 0. So let's have a look at that then. So the first thing to say is to let f of x equal x cubed minus 1, and then to note that here f of 1 is equal to 1 cubed minus 1 equals 0, doesn't it? So x minus 1 by the factor theorem is a factor. Now let's just divide into it then, and I'm going to do this by hand here this time. So we're going to divide x minus 1 into x cubed minus 1. Look at the dominant terms. How many times is x go into x cubed? Goes in x squared. Now multiply out. So we get our x cubed. Then we get a minus x squared when we multiply out. Take the difference. Take the difference. X cubed take x cubed cancels. No x squareds here. Take away minus x squared leaves an x squared. And then minus 1 take nothing is minus 1. Now how many x's go into this? Just repeat the same thing basically. That goes in x number of times. Multiply through x squared minus x. Take the difference. That cancels. Minus 1 take away nothing is minus 1. And then no x's, take away minus x is an x. So put that there. And then that goes, how many times does this go into that? It goes in once, of course, plus 1. So there's our factors then. So here, f of x is equal to x minus 1, x squared plus x plus 1 equals 0. Times that quadratic in a bracket. So there's our f of x. So what I can do is I can scratch this now, just get rid of this lot here, and we can move the problem over, because we've just done the long division. So let's just move that over here, and we can proceed, can't we? With that little subproblem done. So now let's solve this quadratic then. So here we've got x minus 1. No, let's just get the roots, sorry. So this equals 0. So equals 0 gives, well, it equals 0 when x is 1, and also when this quadratic is 0. So x equals minus b is minus 1, plus or minus the square root of b squared is 1 squared, minus 4 times a, which is 1, times c, which is 1, over 2a, which is 1. So i.e. x equals 1, x equals minus 1 plus, now 1 minus 4 is minus 3 with a square root is 3i, root 3i over 2, and the other root is x equals minus 1 minus root 3i over 2. So let's just say let w, one of them, equal just one of the roots. Let's just say it's that one, say for example I over 2 here, and let's work out w squared, see what we get. Let's square this then. So we got minus 1 plus root 3i squared over 2 squared, so that's the square of the top over the square of the bottom, which is 2 squared, which is 4. And this, when we square it, we get minus 1 squared, which is 1, minus root 3i minus another root 3i, minus 2 root 3i, and then lastly we get root 3i squared, which is minus 3. All over 4, oops, all over 4, and that's equal to 1 minus 3 is minus 2, but there's a minus 2 common, so let's put that outside a bracket, because we can then put a 1 plus root 3i here, over 4, which is equal to, the 2's cancel, we get minus 1 minus root 3i over 2, which is the other root. Which is good, which is the other value. So w equals that. W squared is equal to the other value, which is fine. So 1, let's just add them then. 1 plus w squared equals, well, if we add w and w squared, these two together, the plus and the minus will cancel. We'll have minus a half is minus 1. So these are conjugates, so they'll disappear. The complex part will disappear. And 1 minus half is 0. So that's that done. Good. So I think we verified that. We could have chosen w to be the other value and squared it, and we'd have got the corresponding value as well. And the same property pertains. Okay then, that's 11 done.